Definition. Don't use the words you're trying to define in the definition.
Or can you give me an example of a rate of change?
We all use rate of change this morning. Even if you walk, you're using the rate of change. If you rode a school bus, you really use the rate of change.
Okay. Let's write this down. So rate of change, it represents a number that represents, spell it correctly, how slowly or quickly, I might kind of break my own rule here a little bit, something is changing. I think we all know what, if we're changing, what that means, but if we have a rate of change. So, any ideas on what could be a rate of change that you used this morning, especially if you rode a vehicle and drove yourself? Kayla? How fast you're going. Is that something that represents how slowly or quickly your distance from the school is changing? Yeah. So you get in the car, set the cruise control at 70 miles per hour. That is a rate of change, or 120 kilometers per hour. Okay. That is a rate of change. So your speed is a rate of change. So whenever you have something that represents how quickly or slowly something is changing. So you're filling up a bucket of water. How quickly that's filling up, that can be considered a rate of change. Okay. So the key word there, so the best example is your speed. If you going 70 miles per hour, mph, miles per hour. So that is a rate of change. So that means how far do you go, how long does it take you to go 70 miles? That's 1 hour. 1 hour, right? In 1 hour, how far can you go? 70 miles. So if I wanted to write this as a fraction, how could I write it as a fraction? 70 miles per hour, how can I write that as a fraction?
70/1.
So what's the label for the top number for the 70? Miles per 1 hour. A rate of change, 70 miles per 1 hour. So a fraction represents which operation, which math operation? Division. And what's a common word for division? Per. Is it up there? No, there's not one on that list. Okay. So when you have the word per, as in 70 miles per hour, it usually means division, and then you have a rate of change. So that's kind of your clue word if you have something per something else. Inches per second, miles per hour, gallons per minute, liters per second. Okay, those are all rates of change. How many of you go shopping? All right, thanks for being honest, Juan. The only guy that raised his hand. There we go. Okay, I go shopping. I'm I'm not saying you have to go shopping at a clothing store or something. I like shopping Menards, Harbor Mortgage, or something like that. I like those places. I like shopping there. And have you bought anything on sale?
Yeah.
Normally, if you have a percentage off, what word's in that percentage? Per. So if you have a percentage, percent, how does that make it a rate of change? So if you have 25, here's our percentage sign. How do I write 25% as a fraction? Because a fraction means we're dividing, and it's a percent, P-E-R, it should be in there. Yeah. So which we reduce down to 1/4. So percent, remember that equals divide by 100, percent. There's 100 cents in a dollar, so it's divide by 100. So that'd be 25 over 100, which is 1/4. Okay, so anytime you have percentages, that represents a rate of change. How much your discount you're going to get, or sales tax, you can go on top of it. Okay, so we're going to have two different types of rates of change. We're going to have a constant rate of change. And I want you to think of the cruise control, or just think of cruise control with a constant rate of change. You set it, your car stays constant, right? If your cruise control is good. Alright. I've had cars that do a good job with that. I've had cars that don't do a good job with that. Okay? So what this means math-wise is the dependent variable changes by the same amount for each unit of change in the independent variable. Well, Mr. Leitner, you just threw some big words in there. So basically, the change in the y values would vary the same amount as the change in the x values. So we're going to move that up for you. We have some of these, which some of you figured out. Okay, so these two examples, this is on page 79. When I look at this, I first am looking at which one is my independent, which one is my dependent. So which one's going to be my x, which one's going to be my y. So if I think of a graph, page 79. If I think of a graph, what would go on the y-axis? Over here. Oops, that did not work. Just put it over there. So if I was making a graph of this, which of course you don't have to get the answer correct, but what would go along the x-axis, time or distance? Which x-axis, remember, is the independent, and usually always time is your independent. So time would go here. That means distance goes up here. Okay. Now, every increment here goes up how much? Okay, so that's plus 2, plus 2, plus 2, plus 2. And here, what do you have? So is this a constant rate of change? talking about a constant rate of change. It's kind of like cruise control. You go 1 hour, you travel 70 miles. You go 2 hours, you travel another 70 miles. You go 3 hours, you travel another 70 miles. Okay? So how much does this change each time again? 12. How much does this change? So do I take 2 divided by 12 for my 2 divided by 12 or 12 divided by 2? We have to decide which one do we do. 12 divided by 2? Why? Because that's easier than 2 divided by 12? Okay, good. When you're finding the change, remember it's the change in y divided by the change in x. Okay? Guess what we have? Okay, right there. This is what we're going towards. This is the slope formula. That is rate of change. Remember, the change in y go over the change in the x's. So when you have this, your independent variable always goes on top. So this rate of change would be 12 divided by 2. Do not forget your label. Okay. Now your labels just follow the same fraction. Think of that miles per hour. We had miles on top, hours on bottom. So 12 is feet, 2 is minutes. When I take 12 divided by 2, I get 6. What would be my label? Feet per minute. Okay, so the division, however you divide, will tell you how your label needs to be. So in that first question on the assignment, you got to make sure your label is on there and it is on there correctly. Okay. So I want you to look at number 2. Tell me, figure out what would be the rate of change, and put your label on. Number 2, right? You're going to get a decimal on this one. So you're looking at how much does the top change? How much does the bottom change? What'd you get? 3 days? You don't need a calculator. Don't be so reliant on your calculator. It does help. Okay, 3.2. So you're getting a difference of 16 here, right? And a difference of 5 here. 16 divided by 5 would be 3 1/5, which is 3.2. Okay, label would be centimeters. I'm not sure if you can see it back there. That's centimeters cube in the cube. That.
So are we supposed to simplify or are we not supposed to?
Okay. Good question. 3 1/5. 1/5 goes to a nice clean decimal. I'm okay if you put the decimal. We're usually used to decimals. We work with them. We're more comfortable with them. Times that I do not want to put a decimal is when you get something like 2 and 1/3. What's 1/3 of the decimal? Okay. I don't want to